In this video, we're going to discuss Cartesian coordinate systems and drawing vectors on such coordinate systems. And by Cartesian, that simply means the standard XYZ coordinate systems that hopefully you're all quite familiar with. Right, so this is an XY plane. If I wanted to draw the Z axis, it would be coming out of the board directly at you. So can't really draw that too well. So for now, I'll just stick to 2 dimensions of X and Y. So there are 3 very common unit vectors that we will be using in this class. The X hat unit vector is pointing in the X direction. And again, it's a unit vector, so it doesn't contain any information about length or magnitude. It only has unit length, and it points along the X axis. The Y unit vector points along the Y axis, and if I could draw Z, the Z axis coming out of the board at you, then that would be the Z hat unit vector, and it would point directly out of the board at you. One very important thing I want to mention about notation is depending on what book you're looking at or who you're talking to, some people will always use X hat, Y hat, and Z hat, and other people will use I hat, J hat, and K hat. And they mean exactly the same thing, at least in this class. So I sometimes, unfortunately, go back and forth between the 2 because both feel so natural to me at this point. So just know that whenever I say I hat, I mean X hat. Whenever I say J hat, that's Y hat, and K hat is Z hat. And I probably will sometimes go back and forth between the 2. Hopefully that's okay with you. And it's actually, again, a really good thing to know because depending on what source you're looking at, what textbook you're looking at, they might use X or I. All right, so these are useful because any 2 or 3-dimensional vector can be built using these unit vectors, right? So they're going to tell us everything about the direction, and then we need to multiply them by scalars to tell us about the length. So what do I mean by that? Consider this vector A. I could draw this on a Cartesian plane. I just draw the plane around it. And furthermore, I could draw some grid so that I can really think about length relative to the size of this grid that I've drawn. Now this, I could tell you about this vector if I wanted to explain this vector to you. One way to do it is I could tell you its direction by giving you some angle measured here. I've measured it relative to the x-axis, and then simply telling you the length of the vector. Alternatively, notice that if I place the tail of this vector, the head ends up somewhere on this grid, and I've drawn it so that it sort of nicely lands right at an intersection of a grid. So I could define this vector by the point on this grid, which would be 3, 4, right? Because we've gone 3 over and then up 4, right? 3 over and up 4. And what we'll see is these are known as the components of a vector. So 3, 4 are the x and y components of this vector. Now, if we wanted to build this vector out of unit vectors, what we do is take the components, which again are these numbers 3 and 4, which I'll write as a sub x, because that's the x component, and a sub y, because it's the y component. And then I can represent this vector as 3x hat plus 4y hat. And really all I'm doing here is standard vector algebra that we've been learning about. Because what did I do? So what is this 3x hat part? 3x hat is a vector pointing in the x direction and has unit 3 length. So this blue vector is 3x hat. What does 4y hat look like? Well, it's pointing up like this. So by the standard rules of vector addition, 3x hat, 3x hat plus 4y hat, they're already drawn here, head to tail like we normally would, is equal to a, just like we wanted. And so that is how these unit vectors are going to be incredibly helpful to us. They are ways that we can build actually any vector, not only on this plane, but if I had a, plus 2z hat here, then that would sort of rotate the vector, and now it would actually be pointing out of the plane at you a little bit. And so, so that's how you can build any three-dimensional vector you want by simply multiplying scalars by our Cartesian unit vectors. And so, as I said, these are going to be incredibly useful in this course.